Okie doke.
Like orbital. Wait, that's like clicking away. Sorry, that was a very old musical reference. Task 1 instructions. They're also there on the middle side.
Oh, amazing. That's great. Okay.
I even updated them slightly.
Yeah, you should go back one click. All right, quick intro. You need to know this. Sorry, right, we're sorted now. We've got all our IT sorted. Right, ladies and gents. On the Moodle site, you will now find Task 1 instructions. Task 1 instructions is a very exciting Word document that I would suggest you read. And it's one side of A4, so it gives you all the information that you need, and it outlines the first of our mini tasks. So please don't think that this is like going to take you all term. This is supposed to take you, what, 2 or 3 hours at the most? So please don't lose your minds over it. That's why I'm showing you now and saying this is not the portfolio that you're submitting at the end of the year. This is just one of the little tasks that we do as we go along. And a lot of the things that I'm going to show you today are about how you bring data in to an environment that you can then use to layer things up on top of one another and get a view of the data about your site or the data about the context in which you're working. So I'm going to leave you to read this. It's on the Moodle site. I won't read it out at you with, word for word. But are there any questions on this before we just sort of kick off? Everyone know how to find this? Everyone know how to access Moodle? Amazing. Brilliant. Okay. We're back in the room. And one of the things that I did this week is I went into Digimap and I found a place that I thought would be kind of cool. What's the coolest place you could think of in the UK? Brighton? No?
Wales.
Nearly. Anywhere else in Wales? No. Cooler than that. Merthyr Tydfil. Oh, yeah. This place. Oh, man. It's so cool. And, the reason I think it's cool is because of the... where's the overlays? Because look at this place. It's like in the mountains, basically. And when you drive, if you've ever driven through Merthyr, it's like this big valley and it's really cool. So what I did was I got the contour lines, and I'll show you how I did this. I'm going to just delete this, and I'm going to also delete all the buildings as well, because we'll bring those in. Yeah, there we go. All I've done is I've brought in the contour lines from this area of Merthyr Tydfil, because it was voted like the worst place in the UK to live or something a few years ago, and I think, bring it back. Anyway, it's interesting because it's a city or a town that's kind of on a hill. It's got more interest to it. If I did Oxford, we'd be basically staring at a pretty flat kind of landscape. So I just wanted something more to get our teeth into. And one of the things that you're probably going to ask is, like, these are just lines. If you click on one of these lines, all a line is just made up of a whole load of different points. And in between the points is literally actually in this case, it's just a straight line between all the points. So if we click on one of these things, you'll see loads and loads of these tiny dots appearing. And each one of these contours is made up of loads and loads and loads of those points. Except lines aren't a surface. So they're not like the topology of the actual ground. They're just lines in space. They're infinitely thin. So one of the things that you might then think to yourself is, well, I quite like to model the ground as it kind of goes up and down and into the valley and up the hill. And one of the ways we can do that is I'm going to just basically teach you a couple of Rhino commands. You don't need to overthink it. All we're going to do is we're going to, I've shown you how to bring this into Rhino. You just literally click and drag and import it. And I'm going to select all of these things. In fact, I'm going to delete that because that's for something else. I'm going to select all of these things by clicking and dragging with my mouse and select more, and then they turn yellow. In fact, if I turn this to a wireframe view, it's much easier to see on the screen probably. Is that slightly better? Yeah. I click and I drag and I select all of my lines. And then when I've got them selected, I can use a command in Rhino. And a command is just you start typing something. Rhino is always listening. It's like Big Brother. If you type something, Rhino hears it. And it's like its ears are pricked up. It's like, oh, okay, what do you want me to do, master? And you type extract PT. Extract PT. And this is how we interact with Rhino. We just type at it and it does what we tell it to do. Like a very well-behaved child. And sometimes it's really stupid, like a not very well-behaved child. But often it does kind of what you want. So extract point. And then when I click enter, what will happen is all of the lines that I've just selected, all of the points that you saw when I clicked on those lines have now been turned into actual point elements. So I can click on any single one of these and you'll see that if I click on it and go to my properties, this thing is a point. And if I press details, it'll give me the exact coordinates of that point. So it will say exactly where it is in space, X, Y, and Z. And there's loads and loads and loads of them. And the cool thing is, when you then, I've clicked away, so I've lost all my selections. Basically, I've just got a whole load of points now in my Rhino model that I didn't have before. They were kind of there, but you couldn't see them. So I've now created them as actual points. Now what I'm going to do is cell PT. And cell PT means, what do you think is going to happen? It's going to what? It's going to select what? Points. Boom, and they go yellow. Yellow means it's selected. You've learned Rhino in like 5 minutes. This is everything that you need to know about Rhino. It's got its own funny little language, but basically you select things, you do things with them with a command, and then you move on and you do the same, you do the next thing. You kind of layer these processes up. So in your notebooks, you're probably now writing down things like, oh, I better remember the command extract point or cell point. What I tend to do, and you don't have to do this, but what I tend to do, if it's command I'm writing down, I'll put a square around it, because then I know that's a command that I can actually type in. Whereas the rest of my notes are just like normal language. And then I can tell like what's a command I should remember to tell Rhino, and what's just me remembering things for myself. So I've selected all the points, and now I'm going to do another thing with it. I'm going to type PATCH, patch. Like I'm patching a piece of clothing, like there's a hole in my clothes, I'm going to fill it up the best I can. And if you have a whole load of points selected and you type patch, it will give you a little window that says patch surface options. By default, this defaults to 10 by 10. Surface U spans and surface V spans. This feels a bit confusing, like what does this even mean? But the way to think about it is I'm just going to do a couple of these and you'll see the difference, okay? So I'm going to set this to 10 by 10. I'm going to leave everything else exactly the same. I'm going to click OK. And then what it does is it creates like a sheet that kind of tries to match where all those points go. Does that make sense? Yeah? Now, what do you notice about this sheet? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the grid of the patch. It's the resolution of the patch that I'm trying to match onto these points. So if I do the same again, cell PT, patch. If I turn this up and I go 50 by 50 and I click OK, It's going to take a little bit longer because I'm asking it to process more detail. But now I get a finer resolution on my sheet. Everyone following? Happy with this kind of process? And obviously you can go crazy, and I'm not going to, but this is kind of a useful introduction to the fact that it's very easy. Oh, hello. It's very easy indeed. Oh, it's not actually going to let me do 500. Okay, fine. You're going to let me do 200. It's very easy to just, with a tap of a keyboard, do something that I know would actually take this computer probably, I don't know, 5-10 minutes, during which time I'm sitting here like a lemon with nothing to do. So understanding the exponential level of what you're asking a computer to do is quite a useful thing to get used to at the start. And what I'd suggest to you is don't be afraid of crashing things. Save your work all the time. And as you try things out, the temptation is usually, and I did this all the time in my second and third year. The temptation is just turn the number up to like 1 million and see what happens. And usually what happens is the whole thing goes on fire. But the other thing is that you kind of, after a while, get a rough idea of kind of the level of detail that you need with these things and the time that it takes to do it. And it'll be exactly the same process with things like rendering. If you want a really, really high resolution render, you have to wait longer and your computer has to work more hard. But you can also get, by tweaking those numbers the other way, something really, really quick that's kind of most of the way there. And digital literacy in this area is basically kind of understanding what kind of numbers are going to result in you just waiting for 8 hours for it to do its thing, which is usually a sign that something's gone wrong somewhere, and what's not good enough because it just doesn't have enough detail. So I've gone with 100. It's going to take, I don't know, 20, 30 seconds, something like that. Let's hope. We'll see. Do you see how much longer this is taking than 50? Yeah, I've only doubled the number, but it's definitely like more than 8 times the length of time.
With this patch command, is this a planar surface that you're creating?
It's not a planar surface. It's actually a NURB surface, which I'll cover a bit next week. But these lines, they're curves. They're not straight lines. It's not like a mesh. So actually, if I zoom in here, yeah, these lines feel straight because of the resolution of it. But actually, these are mathematical curves. Quadratics, actually. But anyway, so there you go. This is kind of looking about right. If I kind of zoom in here, you'll see, and then probably even better if I put this onto something like a rendered mode, you'll see that basically I've got this patch surface that pretty accurately, given the numbers that I've just chosen, matches all of the contours that I've got in my model. Everyone happy with that? And now I'm done with the points. So I'm going to select all the points. I'm just going to delete them because they're still there in the lines. If I wanted to get them back, I could select all the curves and do extract point again and get them back. So there we are. And we're looking at this. I'm in the rendered viewport. I've chosen to use rendered rather than wireframe. So I've just tapped this little down arrow in the top left-hand corner, and I've gone to rendered. And what that does is it gives me access to change things like the position of the sun, so I can see where the shadows are going to be in my landscape, which is pretty cool. I can see, obviously, as the sun comes up and down in the sky, if I bring it down low enough, this is kind of like the evening sun. I can also go to my light panel here and change the intensity of the sunlight. So maybe I'm going to turn that up a little bit. And now I can see that this area here is going to be in shadow in the evening, and this area here is going to get this lovely light, this golden light in the afternoon. So I can start even planning where I'm interested in building my site, right, within my town. Everyone happy with that as an approach? Cool. Okay. You'll notice that the patch command has this slightly weird thing where at the edges it kind of puckers like fabric, because it's trying to match all the points, but at the edges it just has to go on a little bit further. So one of the things that is useful to then know is this is kind of added an edge to my surface. If I draw a rectangle, which just means typing rectangle into Rhino, I'm going to draw a rectangle around a bit that I am particularly interested in. Let's say this is kind of where my site is. I'm going to select that rectangle, and it actually comes up as a curve within Rhino. Select that rectangle, and I'm going to type trim. And did you use trim in AutoCAD last year? So what do you think is going to happen if I type trim? It's going to trim basically whatever I click. So I've typed trim, and now it's given me, this is cool because it isn't just a one-way conversation with Rhino. Rhino comes back at me with some conversation of its own. And it says up here, in fact, I'll just expand this out a little bit longer so you can see. Select object to trim, select pressing shift to extend, press enter to clear selection and start over. So if you're not sure what to do, just read what it says. And it says select object to trim, and I want to trim this stuff. So I click it, and it goes away from the area outside of the rectangle that I just drew. And then when I'm done, I press enter. Now if I go back to my perspective viewports, I've basically, from the top, like cookie cutted out just the bit that I care about. So I've got rid of those weird little edges of the patch. Does that make sense? And I can delete that rectangle now I'm done. And you can kind of start to see, actually you don't necessarily need to do the whole of the tile that you brought in. It's helpful to just focus on the area that you care about. Let's bring in, if we can, here's my download from Digimaps. I've got some building heights. Question is, which one of these was it? I think maybe it was that one. Let's find out. When you bring these things in, last week we didn't really talk about this, but it's probably worth stopping for a second to think about scale. So you probably did a lot about scale last year, didn't you? When you were drawing scale drawings at 1 to 10, 1 to 20, 1 to 50, 1 to 100. With the digital world, the way it works is that you model things at 1-to-1 scale. So if something is 50 meters high in the real world, you'd model it as 50 meters high. But the units might well be different between different models. And what I happen to know in the back of my mind is that when you bring in something from Digimaps, 1 unit in a Digimap file is 1 meter. Whereas in a Rhino model, 1 unit is usually 1 millimeter. So if you're not careful, you can bring things in and they'll be scaled 1,000 times out of whack. Because 1 meter and 1 millimeter are very different real world units, but one file uses a meter as a unit and the other file uses a millimeter as a unit. I'll show you this. Actually, I wonder if I can actually do this as a demo. So I'm bringing this in and I'm going to say that it's in millimeters because I'm just going to sort of assume that it's millimeters. And I press OK. And it says, oh, I've read all the stuff. It's here. And you're looking and you're like, where's my buildings? Well, I'll show you where your buildings are. They are 1,000 times smaller way down here. I'm scrolling. Look, here they are, but they're really, really small and they're not in the right place because we didn't bring them in at the right scale. Does anyone want to ask any questions about that before we carry on? Because this is kind of like, this is where lots of people's files like start falling apart. Because you're like, oh, I modeled this in millimeters, but I modeled this in meters, and then the whole thing doesn't really work. So I'm going to delete that. I don't want my stuff in millimeters. I want it in meters, please. So I'm just going to tell it that it's in meters and press OK. And now I scroll out, scroll out, scroll out. Where's my stuff? Where's my stuff? Oh, there it is. Oh, it's the wrong one. Oh, no. Okay. Let's try again. Is it this one? Meters, meters. There we go. So there's all of our buildings. Here they are on the landscape. Now, obviously, we don't have things like roads yet, but that's okay because one of the things that we brought in was master map topo standard. I'm going to import this. Again, we need to tell it it's in meters because otherwise it will come in the wrong place and be all wrong. It's thinking. It's still thinking. And it's coming in slightly the wrong place, but let's not worry too much. I know why this has happened. The Merthyr Tydfil actually sits on the intersection of 4 different tiles of Digimaps. So what's going on is that the bit that I was interested in actually only overlaps with the tile that I've brought in by like a quarter of the size. There we go. So what we have now is, I mean, already this is looking kind of nice, like almost as a really interesting kind of exploration of mapping. I personally find all of this hatching just a bit too much. So I tend to do cell hatch, which is what we did. Cell hatch. And it selects all the hatches that we've just brought in, and we can press delete and they'll go away. So now I've got line work mapping that actually sits on the ground right down at sea level. That's at 0 because it's 2-dimensional, kind of flat. Then this stuff has a height. So then we can decide what we want to do about how to display all of that. But we've got all the information that we now need to start actually building stuff. We know where the roads are. We know where the railway lines go. We know where the buildings are, all of the rest of it. So, any questions before I carry on? Yeah, go for it.
So when you import like buildings and roads and stuff, will it, if you've got the unit set to meters, will it automatically import it in the correct location on top of the contours, or do you have how to reposition it if it's not? Right.
So a couple of things there. First is these roads are only modeled as 2D lines. That's all they are. So let's say, for example, I'm really interested in, here we go, this road here. And what I'm actually going to do is switch to my top view here. Here's a road. Actually, here we are. All right, work's calling. And maybe I'm just going to select some stuff here. And I'm going to press Control and select the grid surface. This is hovering up in the air. So now what I've selected is some lines that are like down on the ground, and you can kind of see this. We go down here. These lines are like, no, not these ones. Not the contours. These lines are down on the ground. They're mapping lines. What I can actually do now that I've got a surface there is I can use a command called project. And what that command will do, and we have to be a little bit careful because it does use a lot of compute power, but I'm going to select this surface that I created, this grid, and I'm going to press enter. I'm actually going to change this to loose. Yes. Press enter. And what it will do is because I'm looking through the top viewport, it will take the lines that are on the ground and project them up onto that surface. And it will kind of layer them over the surface in a way that makes sense. And so if I come back to my perspective view, now you can see these lines are actually sitting on the terrain itself. So you can project things up that you choose. I wouldn't suggest you do it with the whole map because it will take ages and ages and ages, but project the lines up that you need, and then you can start building things like your roads into the terrain. That's how I tend to do it anyway. And you can kind of see how this thing down here is kind of mapped to this thing up here. That's the best way I know to do it. So if you start with a surface and then you project up, then it all sort of works out in the end. Cool. What I was going to do was just grab the rest of my notes. Where are they? They are... yeah, go for it.
So I've tried building on like surfaces, irregular surfaces, and it doesn't usually show on the surface. It shows like below.
Yeah.
Could you like show me how you?
Good question. So where are we? The short answer is when you start building things on a regular surface, it will look kind of like this stuff. So this guy here is kind of buried in the ground, and this guy here is kind of floating above the ground. So like it's never quite perfect. So generally speaking, with terrain modeling, what people do is they decide on bits of terrain that they want to have this kind of flowing shape. And then they also go, okay, but this bit, I'm going to put a building there. And the thing about putting a building somewhere is that the first thing generally that you do is you get your bulldozers out and you level the ground up so that you've got a flat base to work with. So rather than saying, how do I build on a wibbly base? The answer is you build a flat base and then you build on that. Does that make sense? So the way I would do it is probably I would draw. I'm just going to do this really, really roughly. I've got basically I've made a foundation base that kind of now sits in this place here. And what I can do is sort of shift that around and maybe rotate it, put it in the right kind of place. Boop, boop. And then what I'm going to do is I'm going to take this terrain. I'm going to trim because I can trim with a terrain. And if I come underneath my base, actually can't see very well now because it's all very confusing. I need to switch this to wireframe mode. There's the base that I just made. You can see it kind of black. And if what I do is I select the underside of that, then do you see it like chops it? And so now I've got this kind of basically this thing that's kind of like a pier in the hill that I can build a house from or whatever. So that's the trick, that you never build on the wibbly ground. Happy?
Yeah, thank you.
Cool. There are lots of things I could show you here, and actually the more we get into the modeling side, we'll start to actually what I want to do is kind of give you the tools to bring this data in and start kind of analyzing your site from a starting point, because that's one of the first things you're going to be doing. Here we are. I'm going to switch gears a little bit, and I don't know whether this is going to get recorded very well, so I apologize for people watching the recording, because I don't think I can share. I want to show you something on an iPhone, but I don't think I can share my iPhone screen with my computer so that it goes onto the recording. But I can show you the iPhone screen here, right on my desk. So what I want to show you is a different scale of getting things into the computer, because this is big mapping town scale. But sometimes you want to get something into a computer that's much smaller. And where do you find the information? Well, what you can do is there are quite a number of apps that do this. I personally have used an app called Polycam. Oh, hang on, I'll just do that. Polycam. This is on the screen. And one of the things that you can do with Polycam, which is very cool, is if you press this little plus button down here, what I'm going to do, and you kind of will find it difficult to see this, but can I do it this way? I don't know. I'm just going to take a whole load of photos of. I won't even try. It's not going to work. I'm going to take a whole load of photos. This is a perfectly normal iPhone. You could do this with a super old, literally, I think Android would work as well. I'm going to take a whole load of photos. I mean, any smartphone with a camera. That's all you need. I'm basically just going to hold this button and walk around an object, maybe this desk or something. I'm going to walk around this object, and it's going to take, like, I don't know, maybe something like 100, 200 photos. It'll just automatically keep on taking photos. And you could do this manually. You could literally just, like, walk around you could scan a person if you wanted to. Hundreds and hundreds of photos from all different angles. And then what it'll do is it'll take all of those photos together, stitch them together, and make a 3D model based on what it understands of the photos that you've just taken. So this is getting data of a different scale into the computer. This is stuff that you can hold in your hand, stuff that you can walk up to in the city. Let's say there's maybe your project has a very, very, very important post box, and you want to model that post box exactly. Well, you grab your iPhone, you take 200 photos of it from all different angles, and then you send it to a fancy thing in the cloud that basically does a whole load of number crunching, and then it will give you a 3D. It'll actually give you a 3D point cloud, but we'll come to that in a second. Right, here we go. I'm just moving around the desk, and basically I'm now at 3 photos, 4 photos, 5 photos, 6, 7, 8. Oh, I need to keep moving. And I want to go up and down as well as around. I'm kind of imagining like a dome completely surrounding this object. This incredible desk designed by some amazing architect, I'm sure. I'm up to 41 photos, 42. If you have a laptop with a fancy graphics card, the thing that you probably want to write down is Meshroom. If you have a laptop with an RTX, like CUDA graphics card, even like quite a small one actually, Meshroom, like mushroom but with an E. Meshroom is free open source, and all you do is you just take all these photos on your phone, you upload them to your computer, and you just say, hey, make me a point cloud based on all these photos. And it will use your computer's graphics card to crunch those numbers. And it's doing the same thing that your eyes do, right? If you have 2 photos of the same thing that are slightly different apart, and they look a bit different, and one thing looks further away, then your brain can work out depth and 3D from just 2 photos. Obviously, computers are nowhere near as good as your brain because I'm having to give it something like 100 photos, 200 photos. Yeah?
I see you doing something like this before. It was related to LiDAR scanning. Is this the same thing?
You can do, if you've got a really fancy iPhone that has a LiDAR scanner on it, then you can use the LiDAR scanner to, in the same app, you can get a 3D model almost instantly. My experience of using a LiDAR scanner is that it's really great for kind of larger things like a room, but it's not very good at small detailed things. But play with it. I've always been impressed with some of the LiDAR stuff that's out there, especially the like new Apple things. If you've got like the Pro 14, 15, those kinds of numbers, there are loads of apps that will read that LiDAR data and turn it into a mesh model for you, which is it's pretty cool. That for a while, the other thing that uses LiDAR is actually your face scanner. So if you've got a face recognition phone, then the face bit is actually also scanning depth. And so if what you want to do is scan your own face, you can do that with the forward-facing camera rather than the backward one. And it looks pretty cool. Right. I'm going to click done. And now what's going on here is it's going to take a while because it's quite a large file. Processing mode, upload and process. Hopefully this works. I'm going to leave that going. Keep app open until upload finishes. I'm going to upload it, and I'm going to use the photogrammetry mode. And all the photogrammetry is doing that same thing that your brain does, same object from two angles, and it uses that to work out depth, and then turns that into a point cloud. This is going to take a little while to focus on, so I'm going to carry on and give you some other information, and then we'll come back to it. It'll hopefully be like, here's one I made earlier. Let's find out. Okay. Climate data. Who's excited by climate data? Yeah, I get really excited by climate data. I think I get unreasonably excited by climate data. So if you just want to, as I'm going, if you just want to wave and say, yeah, all right, we get it, move on. I'll take the hint. The cool thing about various academic institutions is that they've worked really well with various people who have a vested interest in creating data. So when it comes to climate, there are certain organizations, and I've got one very specific organization in mind, or kind of organization in mind, whose job involves very, very closely monitoring the weather, and that is airports. So airports have access to all sorts of data, mostly around, is it going to rain? Where's the wind coming from? Because if you're going to land a plane, you need to know where the wind is coming, right? You need to tell the planes, oh, the wind is coming from the northeast today. You might get blown off course, right? And so they have really, really sophisticated weather stations at airports. And then what this organization, onebuilding.org, did was they said, why can't we get that data shared with us in the building world? Because we also need to know what the weather's like over a long period of time so that we can design buildings that cope with the climate well. Does that sort of make sense? If you know that it rains loads in the place where you're building, you're going to think very carefully about what waterproofing you put on the roof of your building. You're not just going to go, hey, well, just put a tarp on it and hope it's going to be okay. If you know that it's really hot, you're going to think very carefully about how you ventilate and cool your buildings. If you know that it's really cold, you're going to think very carefully about how you heat and insulate your buildings. So the data that you can get from these kinds of places is really, really helpful for you choosing how you're going to design your building. So climate.onebuilding.org, there's a link in the lecture outlines. You can just find it on Moodle and click. And what we'll do here is I'm going to go on the left-hand side to Europe, region 6. And I'm going to find GBR, British Isles. These are all the weather stations in the British Isles. And within that, what I tend to do is I tend to go for the largest airport I can find because I know their weather stations are the most sophisticated and it's got the most data. Some of them, it's like someone's put like a wind speed meter in their back garden, and it's like, oh, great, well, thanks. But, I'll get a Heathrow Airport, please. So here we are. Where's Heathrow? Can anyone see it? I'll just do Control F. Heathrow International Airport. There we go. So what this is, this guy here, 2004 to 2018. Can you see that at the end of the file name? So that's the average of all the weather between 2004 and 2018. This is the average of all the weather between 2007 and 2021. And what it means is it's the whole year of data. So it'll tell you what an average July 21st is during those periods. And the one at the bottom, 2009 to 2023, that's going to be the most up-to-date one, right? So why wouldn't we go with that one? So I'm going to click that. It downloads a little zip file. Here we are. I can extract that zip file. Is everyone familiar with zip files? I forget because sometimes people say, what's a file? And it's like, we do have to go slow, and that's okay. I'm going to extract this zip file. Whoop, and it gives me a folder. Within the folder, I have a whole load of files. And you're going to say to me, why are you getting excited about this? For a start, I can't open any of these files. They're not DWGs, they're not Rhino files, they're not Word docs, they're not Excel spreadsheets. You can't open them. What do I do? Well, there's a really good one, which is EPW, which is Energy Plus Weather. And Energy Plus Weather, in the lecture outlines, you can visualize EPW files using some of these links. So literally all you need to do is click on this link, and it's called EPW Viz. It's like an online visualizer for EPW files. And it says drag and drop the EPW file here. Well, here's my EPW. It says .epw at the end. Drag and drop, and boom. Here is the temperature of an average day for the whole of the year at London Heathrow. So let's just zoom in a little bit here so you can see. I'm actually going to switch this to SI units, so we use degrees C rather than degrees Fahrenheit, because I'm not that old. So let's just look at this for a second. Take a moment, take 20 seconds, chat with the person next to you. What's going on this graph, on this plot? I'll help you out. Oh no, it doesn't hover. Okay. All right. Who wants to start us off? We'll start somewhere at the back. What's going on in on the graph here? What can we see? This is why I get excited about data, because they're like, data's boring, but then you can visualize it in these cool ways. Someone kick us off? Tell us something about what's going on with this data. Okay, yeah, someone from the front. Oh, the keen beans at the front. Go for it. Impress us.
This is just like research?
No, go.
Right, so it's just like the temperature. Like
Yeah.
over time of July, you'll see like from 7 to 11, you'll have maybe like 27.5 to 30.
Yeah. So there's like this map here has a color, and that tells you what temperature it's going to be. Do you notice that all of these guys are like divided into little rectangles? What do you think a rectangle is? An hour. Yeah, cool. So what this is not just in July it's hot. This tells you exactly how hot you should expect it to be for every hour of every day of the year, which is like a level of detail that you don't get by just kind of like going to BBC Weather and being like, hey, what will it be? Now, this isn't a forecast, right? This is just an average of the last kind of 15 years. So what it's saying is you should probably expect that in July at 4 p.m. it will be somewhere around 23 or 27.5 degrees. You had a question?
Yeah, I was going to say, there's every at the start or towards the end of each month, there's like a streak of heat.
Yeah.
How does that make sense?
Well, interesting. I don't know. This is just the average of the data. So what it's kind of saying is there are moments in the year where there's a sudden kind of like spike in heat, and then it kind of goes back down again. Now, likely that is probably quite dependent on the local ecosystem, the local, they call it microclimate. So it could be that, I don't know. I'm trying to think, but you know how it's been recently, right? It's summer, and then it's kind of like it's winter, and then there's summer back again, and then it's winter again. It kind of has this kind of like cyclical sense to it. And weather does tend to have this idea of like when it gets really cold, then the next thing that happens, it will feel a lot warmer, right? And if you've had a really long dry spell, well, what's going to happen? There's rain coming. You know it's going to come, and it's going to be really awful, right? I mean, you'd need to speak to a climatologist or a weather scientist about it. But the fact that what I like about it is that you can have a really detailed conversation about what will it feel like at 3 a.m. on the 1st of February in and around my building. And it's more than just, I know it's going to be cold. It's like it really drills it in that at 6 a.m. on end of January, it's going to be like -4. And you should expect it to be -4. And you should probably build your building accordingly. So especially in the UK, it gives you a real good sense of the kind of variety of weather that you've got. Now, there's loads of other stuff going on here. You can look at these to your heart's content. Cloud cover in the UK is basically like, it's cloudy all the time. So don't worry too much about that. You've got here things, you can actually slice and dice this data. So you can say, hey, I want to know all of the times in the year or the day where the temperature is below 10 degrees. Does that make sense? The dew point temperature actually is below 10 degrees. And so what that's saying is kind of January, February, March, April, and November, December, the temperature is less than 10 degrees. And if you've lived in the UK for a while, you kind of know this is true, right? Then, because it's an airport, a windrow's really, really useful. Have you looked at windrows before? Yeah, I'm not going to spend too much time on that. But basically, it's saying the wind is coming from the west. And in fact, actually, this is interesting. If I expand this back out again, no, this doesn't adjust. The wind is generally coming from the west or the southwest in Heathrow. That's what it's saying. One more thing that you can drag EPW data into, and what we'll do here is this is called NSIMS. It gives you there's a little map up here, really, really tiny. I don't know whether you can see that. I'll zoom in. A little map with a pin in it, and you click that, and it says, do you want it to know your location? So you say, yeah, okay, you can know my location. And I'm going to zoom in. All these are basically mapped locations of these. So these are all the UK EPW weather stations, and these are them on a map. So it's exactly the same data, it's just presented in a different way. Let's go and find something near Oxford. There's Benson, RAF Benson, which is kind of just south of Oxfordshire. And I'm going to choose the 2009 to 2023 data set and click Open in Viewer. And it's going to think for a while. And then here's all the data. I mean, who cares about tables of data? But you can go to Overview, and now you've got this. These are the temperatures across the year. So this is where what the temperature should kind of you should expect it to be across the year. You've got solar radiation, so this is how much sunlight you're going to get. You can also slice and dice this windrows. So I can say, hey, this is a cool little animation. I'm going to turn off strong breeze and near gale and gale, and see where the fresh breeze is coming from, because it may not be the same place as the whole of the rest of the windrows. There aren't many gales in the UK. There may be some strong breezes. Yeah, not that many. And obviously, light air, light breeze, not doing a huge amount for you. Anyway, there's a couple of tools that kind of get you into the idea of where this data can take you. And obviously, so far, we haven't done anything particularly architectural with that data. But it's important for you to know that it's there because you're designing for a climate and you're designing for a context. And that context has quite a lot of extremes going on. I showed you this very, very briefly last week. This really, really cool visualization tool. It's called earth.nullschool.net. There's a little menu down here, which isn't just showing you, this is actually the wind going along the surface. This is wind at surface, it says here. This is the data set that we're currently looking at. And this is live. So this is where the wind is going in the UK and around the UK. And you can see, I wonder actually whether we could go back a couple of days and see, this is hours. If we go back a few days, we may well see the path of, here we go. Can you see there the path of Hurricane Helen? And obviously you could play this through. Anyway, there are other bits of data that we've got here. We can go to ocean mode. And what this is showing you is where the waves are going. So each one of these little jobbies like floating about, that's a wave. That's where the waves are pointing. This one I think is really interesting. This is chemicals in the air, in the atmosphere. Chemicals. At the moment, we are looking at concentrations of carbon dioxide on the surface. Yeah?
In terms of exporting all this data, do we have to take a screenshot? Or is there
With this, you just have to screenshot it. Yeah. I mean, but with that screenshot, you could take that into Photoshop and basically isolate the colors that you want and then layer it up against another map, for example. So the information's there in pixel form. Then there's not, you can't easily reproduce this. You could do it with some scripting, but it would take you way longer than it needs to. And just the easiest thing to screenshot.
Do you have a way of screenshotting a smaller monitor size but having a higher resolution?
It's a very good question. Not off the top of my head, but I'll have a think about it. I'll come back to you. What these are showing is these areas here are where there's high concentrations of carbon dioxide on the surface. And what you'll notice as we kind of move through time is those wispy areas of where carbon dioxide is generated get kind of pushed around the globe. And there's some really interesting stuff that happens at the equator. You can see some really, really interesting kind of fluid dynamics simulations of what happens to carbon dioxide in the atmosphere. But if you want to get an understanding of what's really going on in our global sense, these kinds of visualizations are really, really exciting, I think, anyway. If I switch to currents, this will give me not just where things are going, but basically these lines here are are kind of lines of equal pressure. So they're kind of the equivalent of contour lines if you're looking at terrain. But I think they also look pretty beautiful. Right. What we're going to do is it's 10 o'clock. I'm going to give you a very brief, because we need to fit quite a lot in, pause until 10:05. So just about enough time to stretch your legs. And then when we come back, excitingly, photogrammetry has worked. So I can tell you that there'll be some exciting things to see. Okay, 5 minutes. I'll see you in a few.